Hooch has been sitting there with his hand up very patiently, and I can see in the chat there's a bunch of questions. So Hooch, if you want to get onto some of the questions now for both James and for Sean, I think there's a couple there that James would probably like to have a crack at.
Yeah, and I thank the attendees for their patience. We've got a question that's come in. Has the 320 millimetre minimum size limit forced anglers?
Oh, we did that one. Well, we're going to come back to that one.
I might just add a little bit on that, because it actually, there is a bit of a reference to particularly female fish. So we know that males and females grow differently, and that females are larger than males in their growth rates. What's really interesting with flathead is our sex ratios, particularly in the summertime, seem to be biased towards females. And some of the really interesting stuff is that males do appear to be maybe in the deeper water than in the shallower water. And there's a clear seasonal cycle in the male sex ratio, or for male-female sex ratio with season as well. So, there's some very interesting things going on with sex. And I think I already talked about the 320 size limit before.
Yeah, cool. I had a bit of a technical issue and must have been dropped out at that stage. The other one we've got has come in. The Tamar has a lot of stunted fish, and I think it's been stated most are under the age of 5 years of age. So how does the example of stunted growth apply to a lightly fished estuary such as this, and where did they go?
It's your backyard, James.
Yeah, okay, that's my backyard. I actually wouldn't say that the Tamar is stunted. The fact that they only get to 5 is not an evidence of stunting. If they were like they are in Georges Bay, where they're 14 years of age and still undersized, that is what I would call a stunted fish. My theories on the Tamar is that once they hit sexual maturity at about 4 to 5 years of age, they leave the Tamar, and I believe that they don't come back in the Tamar because of that 3 metre tidal flow, and then they sit out on the coast. And there, I would say that the Tamar is heavily fished. There's lots of shore-based fishing and those sorts of things. And then also, because of that tide, the fish might aggregate into those calmer bays, which is where all the boats anchor up and then fish anyway. So there are loads and loads and loads of fish in the Tamar. It's a huge nursery recruitment zone. And I believe, and we've got data going back to the early 2000s from the Tamar. It has a really nice broad range of sizes for 2-year-olds, from 14 to 30 centimetres for a 2-year-old. And so although people are saying they're catching lots of little fish, they might all be 2-year-olds. And so it's not actually a stunted population at all.
Yeah. So I'll gather up a couple of the questions in one if I can, and that's really around mortality. So we had a question before we got on tonight saying fishing mortality versus natural mortality is a measure of sustainability. Can you explain the way this assessment is made? Like, what are the range of factors that are considered in natural mortality? And through the questions we've been receiving now online, people have been asking questions about the impact of climate change on mortality, of seismic testing, whether or not there's sort of a cycle of dieback of large populations, and talking specifically about seeing less large bream in the Derwent, and doesn't think that that's probably related to fishing mortality because it's quite lightly fished. So
all right, so that we're about to jump into fishing mortality and all those fun things. So I will clarify one comment here, that comment about the observers. I think the 4 trips in Commonwealth waters were witnessed with observers, but none in state waters. So no, it was 4%. 4% of all Commonwealth trawl trips have observers on board, so that's outside the 3 nautical miles. We did 3 trips on a Danish seiner that was fishing for whiting, so in the whiting grounds, so a bit closer to the coast. And on those 3 trips, there were only 19 sand flathead discarded. I think there was like 45 kilos were kept in that year total across the entire Danish seine catch, but 19 fish were discarded because they were most likely undersized. How far out were observers taken when fishing on these trips? Well, again, it's the whiting grounds. They had good catches of whiting, so this was their key fishing grounds where they'd be fishing. This data could be manipulated as the further offshore you go, the less of the sand flathead catch. Yes, but also the less of the whiting catch. So again, they're trying to maximise their commercial operation. Take the point. I think it's part of the scalefish review. I believe they're looking at VMS, so that same system we were talking about before, to track the boats. But from my mind, there is not hundreds of thousands of tonnes of hidden commercial catch going under the radar here. So that to me is fairly clear from what we're seeing from the data, but it is being recognised, and they are looking at, as I said, considering putting VMS on these vessels, the Danish sailors. All right, mortality. What time is it? 8:10, perfect time for some maths and statistics. James, do you want to have a crack, or should we just give them
okay.
slide?
This is my my level 3 fisheries assessment class, but instead of looking at that maths, if we can go to the next slide. So this is a little animation I tried to do to try to explain what is the difference between natural mortality and total mortality. So the way that we determine natural mortality is based on a % survival. And if we use an observed maximum size at 20 years of age, it's fair to say that 0% survive to 21 years of age. And so therefore we can then say, click again, Sean, that about at 20 years of age, only 1% survive. That's all the information we need. We can work backwards to survival to 100% for the younger the year. And if we click again, Sean, we can see then we have a rise over run equals the slope. That's the mathematician in me. And that slope is actually the rate of natural mortality. Okay, so that's a bit of maths. If we go again, we can use this M and put those values of 1% and 20 years in there and get this magic number, 0.23. Well, what does that actually mean? What that means that if a fish lives to about 20 years of age as its maximum age, approximately 20% of the survivors each year will die. So if you started with 100 fish, the next year there will be 80 fish. And then the next year there'll be 64 fish. And there'll be this decay until by the age of 21, there are 0 fish left. So if we know maximum age, then we can determine what our natural mortality rate is. For total mortality, we do it sort of starting at the beginning. And so we actually get a whole pile of lengths or age structures, and we plot that up and we look at that line and that slope. And in this case, I'm calling this a total mortality rate of about 0.46. And if we then compare that to natural mortality, we have this equation that fishing mortality will equal our total mortality, take our natural mortality. Okay, and click again. So if we use this as an example, 0.46 take 0.28 equals 0.23, and therefore F equals M, fishing mortality equals natural mortality, and that's that exploitation rate that fisheries try to aim for, which is about 0.5. And what that basically means is 50% of deaths occur due to fishing and 50% of deaths occur due to natural causes. But if we go and do our stock assessments and we see that this total mortality rate is really, really steep, then that exploitation rate can go up, and that's how we sort of look at the ratio between total fishing mortality and natural mortality.
How was that one, Hooch?
How was that, Hooch? Yeah.
Making total sense for everybody?
Yeah, I know that's hard at maths. It's basically the slope's shallow and then the slope is steep, and we look at those two perspectives.
So the main point is we're not adding up what we think that the predators are eating, what we see lying on the sea floor, what we know is taken from the catch. It's based on population dynamics. So again, this is a well-studied field across a range of sciences, and it is basically the basis of fisheries assessments across the globe.
Just for my mind, what's the test against the theory and the maths there? How do we back that with what you're seeing out there?
All right. Well, so that's the theory. So now we'll put it. That's a beautiful segue, Rich.
It is.
So,
yeah.
So James, are you want to keep going?
Yeah, I can keep going. So there's 10 areas here, Flinders Island, and from the long-term surveys. And what the graphs are on the left are our linked frequency distributions. Okay. And so what we can see, the very top one, which is Flinders Island, up through there.
James, I'll just give a bit more on the length frequency distribution, just to explain that. So basically, across the bottom of each of these graphs is the size of the fish that we're catching. So starting at 2 centimetres to 60 centimetres, so, and then the frequency, so the number of fish that have been caught in each of those size classes. And then each graph is a different region. So Flinders Island, northwest coast, central north coast, northeast coast, east coast in the north, east coast south, southeast coast, Channel, Tamar River, Georges Bay, thank you.
Yeah, and the black line is 32 centimetres.
So the size limit.
And this data is actually all data pulled from 2018 to 2022.
Go.
And so, Sean, I think this is animated. Yeah, and so if we look at the L bar, this parameter here, this is the mean size of fish greater than our legal size, 32. And so we can generate that value and plug it into the equation up the top called this Bourbon and Holt Z equation. And what it shows us is total mortality is relatively low at Flinders. We are very high in those two areas, and then all the other regions are extremely high. Yeah, you can actually animate again, click again, yeah, and so all of those are color coded. So that's that rate. They have a really steep line. If we want to use, that's using it on lengths. This is using it in the age structures of legal size fish, only legal size fish with age, and it shows very similar trends. In the Flinders Island is relatively lightly, has a low death rate, and then the others have these sort of high, very high, and extremely high mortality rates for their three regions. Mate, and the other point here is that those rates are well above the exploitation rate of 0.5, with the exception of Flinders Island.
Yeah. So the big thing here, and this is, and we touched on, I see some questions coming about recruitment and various things and other things that may be affecting things. So we will come to those, but the main thing with Flathead is they are coming through in numbers still. Like there's not as many as there was, but there's still reasonable numbers. It's this knife edge as soon as they hit the size limit that they're being removed from the fishery that tells it's fishing, and not unless the seals are also acknowledging the size limit and only eating fish above 32 centimetres, and unless the salmon farms are impacting just fish greater than 32 centimetres. This is one of the strongest bits of evidence, is this mortality that shows that knife edge decline once they're hitting that size limit. And we saw the same thing when it was 30 centimetres. So you had that same knife edge, and over about a 2-year period, when the size limit was increased, it was hard to catch a flathead, then they grew through to that 32 centimetres, and that same knife edge came back onto the fishery. So that's where we know we're at a point that it's the fishing effort, the fishing mortality is very high, and that's what's driving that overfishing.